तो स्टार्ट करते हैं क्वेश्चन नंबर 4 से। The transition elements are able to form stable complexes with a wide range of molecules and ions. State the meaning of transition elements. Okay. So, transition element are those which have a incomplete or partial filled d subshell when they are in their ionic form. So I can write elements which can form one or more stable ions with partially filled d subshell. Okay. Then next part, the d orbitals in an isolated transition metal ion are degenerate. In complexes, the d orbitals occupy two energy levels. We all know when a ligand is formed, when a ligand attaches to the transition metal and it forms a complex, in that complex, the d orbitals is split into different energy levels. Complete the diagram to show the arrangement of d orbital energy levels in octahedral and in tetrahedral complexes. Okay. So when you recall the shape of octahedral complex, in octahedral complex, all the ligands are bonded on the axis, and in tetrahedral complex, all the ligands are bonded between the axis. So in tetrahedral complex, the orbitals which are between the axes have higher energy, and the orbitals which are on the axis have a lower energy. If I label them, then it is dxy, dyz, and dxz, and these can be dx square, y square, and dz square. In octahedral complex, the orbitals which are on the axis have a higher energy, and the orbitals which are between the axes have lower energies. Okay. One more important thing. This same splitting goes with the square planar complexes as well. Is this clear to everyone? So,
Yes, sir.
square y square, and this is dc square. And this is dxy, dyz, and dxz. Okay. Now, sketch the shape of two d orbitals. Okay, we have to draw only two d orbital. One d orbital from the lower energy level in octahedral complex. So these are dxy, dyz, and dxz. And one d orbital from the higher energy level in an octahedral complex. So it can be these are dx square y square or dz square. Okay, so I think it is easier to make dz square, which is higher energy level. So here I will make two lobes on z-axis, and then a disk like this to show dz square. Now, when we talk about dxy, dyz, and dxz, these are actually between the orbitals. So if I make this one, so it is actually, this one is dz square, and this one is dxy, because the lobes are between x and y axes. Okay, is this clear to everyone?
So for the dxy, will it like touch the z-axis?
Sorry?
Will it touch the z-axis for dxy?
No, see, these are actually on the between the x and z, sorry, x and y axis. It's not on z axis. Okay, 1 minute, I will draw it again. Okay. See, for example, if I am drawing over here like this, so see, they are actually lying between x and y axis. The orbitals are lying between x and y axis. Now it is dyz or dzy. Okay, but if I'm drawing it like this, so see, this is a y-axis and this is a x-axis. So the lobes are between x and y. In the similar way, I'll draw them over here between x and y. Is this clear?
Yes, sir.
Okay. Now, C part. EDDS4 negative and EDTA4 negative are polydentate ligands that form octahedral complexes with Fe3 positive. Okay. The formula of the complexes are FeDDS negative 1 and FeDEDTA negative respectively. On the diagram of EDDS, circle each atom that forms a bond with Fe3 positive ion in FeDDS. Okay, so we know that from the ligand, the atom which have a lone pair actually forms a dative bond with a ligand. So if you look at EDDS for negative, these nitrogen have a lone pair and these oxygen have a lone pairs. So we'll make a circle around these atoms because these are the one which can bond with the iron.